Good morning and welcome to this session of the BIM Harambee Africa, and today the 29th of October I'm going to be talking to you about digital twins. So my name is Matchett. Just reflecting on the conference so far, there have been a lot of presentations that have covered so much ground on BIM, on digital engineering and the way that our industry is changing, and really a lot of passion in the conversations about how our continent is going to embrace modern technology, and just really enjoying the conference so far. And I encourage you to go back and have a look at whatever you may have missed in terms of BIM, or looking at different case studies, looking at different learning opportunities, and really hope that today's session on digital twins will add to your understanding. So, my name is Matchett. I am a civil engineer. I work for a company called Zutari. I am also a biker in my spare time, a drone pilot, and I love all things technological. So for me to talk about digital twins is really to talk about something that I'm very passionate about. So what you can see on screen is a piece of information. It's a very old piece of information. In fact, it dates back almost 6,000 years. And it represents a contract between two parties. It is indeed a payslip, and the characters that have been inscribed on this clay tablet are representing how a worker is going to be remunerated for the work that they need to do. And in this particular case, we are told that they are being paid in beer. Now, tablets and information, I think in our modern era, are quite familiar to us. We work on tablets all the time. They just look a little bit different. And this is a simple example of how the digital and technological world have been taking us forward as civilization. Tools and digital opportunities are aplenty, and I think all of us are surrounded by technology every day, whether it's drones and scanners, or different types of software and applications to do modeling, mobile applications for gathering data, or even the Internet of Things and all the sensors that are connected to our physical world. All of these opportunities are really opening up our scope as engineers and practitioners in the built environment. The question is just, how do we use these effectively, and how do we derive value for the end users of the infrastructure that we are involved in? Digitization is really a process of converting from the old to the new. So in the case of our clay tablet, that information is now being digitized as an image on a digital device. That is really a basic process, and all over our industry we are seeing efforts to scan paper copies of documents and to convert from analog mechanisms of data capture to more digital means. That is the first of 3 steps in a journey to transforming your organization or your business or your way of working. The second important part is really understanding how that digitized information should be applied to simplify the way you work. And digitalization is, by and large, the process that most of us are grappling with. Is what does all of this digital information do for us? How does it change the way we look at our processes? How does it change the way we work? How does it increase our efficiencies? But ultimately, digital transformation is where we want to head to, where we want to get, so that by using all of this technology, by using digital information, we're actually able to change fundamentally the type of business that we're in and the way that we do business with each other. And this digital transformation is really the topic of digital twins and BIM, as we see a fundamental shift from the old ways of doing engineering to the new ways of communicating and doing engineering. I always say that with BIM and with digital engineering, the fundamentals of math and science don't change, but the way that we apply them and the way that we communicate and share ideas is constantly changing. So digital transformation, as I said, is all about information, and when we start looking at the actions associated with information, you can see that it really covers the spectrum, from gathering and generating information in our surveys or in our designs, to organizing those in common data environments, and then how we use that information for a specific purpose. We share it between different stakeholders, we store it and are able to retrieve it when we require that information. And the aim of that is to enhance our business processes. Building information modeling, or BIM, has been spoken about much in this conference so far. I like to mix it up a little bit because I'm a civil engineer and from a roads background. Buildings are not my core. I'm really a roads engineer. So I like to mix this up and say, well, it's about modeling information about building. And this opens up the scope of BIM to all the disciplines in engineering. So it's not necessarily about a building or a skyscraper or a hotel. It could be about a water treatment work. It could even be about a road network. And really the key to me with building information modeling is the information. How do we model that information so that it describes what has been built, what needs to be built, and how that needs to be managed so that we can really derive the maximum value out of that asset. So the fundamentals of BIM, I think by now everyone's familiar with this, but I think it's worthwhile just showing this link. 3D models are the way we understand our virtual representations of the world these days. No longer do we depend on paper copies and flat drawings. 3D models, I think, are by now the norm. And many people got very enamored with 3D models, and I think the industry got partially distracted with 3D modeling for a while. But I think we're starting to realize that the eye in the middle of that picture is the most important part. Linking information about the assets that are represented in 3D, representing those with information about time, cost, sustainability and operations. That really is the core of BIM, and that is where the value lies. And so today's conversation about digital twins says, how does the BIM world take the next step? Where do we go to next? And what is the value proposition of a digital twin? I think it starts with looking at the life cycle of an asset. And so every asset that we're involved in, regardless of which part of the built environment you come from, there's going to be this continuum of information that grows throughout the life cycle of an asset. So in this case, the cartoon represents a building or a portfolio of buildings. And we would go through a whole series of planning, conceptual designing, through procurement and construction, and then go through commissioning and beneficial occupation of that facility, and zooming out, looking at the asset management and the portfolio management of a collection of these assets. And throughout the life cycle of that building, the intention with BIM is that the information does not start and stop, but that there's a continuous growth of information throughout that project life cycle. So the information that was generated by the planning team is used as input into the conceptual design and then further into the design process. Through procurement, more information is added in the form of contract information. Through construction, a huge amount of information needs to be added to really take the information that was design intent and convert it into as-built, and make sure that all the OEM information, the maintenance information, etc., is prepared for commissioning, so that at the occupation point, the operator is provided with more than just a set of keys, but they actually are provided with a very valuable data set that they use for the facilities management and operation of that asset. There are many of us that are involved in this process, and whether you're an urban designer involved in the front end of a project, or a construction professional and contractor involved in delivering, or later on in the facilities management and ownership stage of the project, all of us are actually participants in this BIM world. So depending on where we sit in the industry, I think currently in 2020, there are varying degrees of BIM adoption throughout the various different pockets of the industry. And definitely each group of people has something to grow. And this growth path, the opportunities to develop further, are really going to lead to a rich use of BIM as a means to collaborate, to grow information and accumulate information about assets, and ultimately derive maximum benefit from those assets. So when we look at the initial half of a project through planning, design, procurement and construction, there really is an industry-wide focus on BIM. And this conference and the intent of this conference is really to drive the adoption of BIM, the use of the tools within the suite of software associated with BIM, to use these effectively, whether it's in reality capture and modeling, or design, or quantity takeoff. We want to see BIM used extensively so that we have consistency throughout the industry, and that we can start delivering a consistently excellent product in Africa. Beyond construction, we enter another world, which is the beyond BIM world. And this is the world where digital twins really take root. So let's take a closer look at what digital twins are and where they come from. Dr. Michael Greaves is well referenced in literature as being the father of the digital twin. He and a colleague from NASA were looking at aerospace product models and how a computer model of a physical asset could assist them to understand the asset and to manage it throughout its life cycle. And as they unpacked this concept further, they developed this short definition, which says that the digital twin is a virtual image that contains all the information about a physical product and reflects it throughout the entire product life cycle. And those four areas that I've highlighted really encapsulate the core of what a digital twin is for anyone who wants to develop a digital twin or to understand how it fits together. Those are the important parts to remember. So if you don't remember anything else, it's definitely a virtual image of a physical thing. It contains the information about that physical thing, and it reflects it throughout the product life cycle. So it's not just the design phase or not just the operational phase, but it is throughout the entire product life cycle. All of our real assets, be that a building or a factory or a water treatment works, each of those real assets that we engage with need to be acted upon. So whether it's maintaining that piece of infrastructure or modifying it to change its characteristics or improve it, or to decommission it at the end of its life cycle, those actions are acted upon on the basis of decision making. And in decision making, there are strategic, operational and commercial decisions that get taken on a very regular basis. And the means to take those decisions needs to be informed by something. And by and large, that is the business drivers of the organization that owns those assets. And so as the life cycle of an asset progresses, it deteriorates over time, it needs to be tuned and upgraded to meet changing demands, and the basis of those decisions then to act upon the reality are then linked to those business drivers. Business drivers in turn need data or information. It's impossible to just take responsible decisions based on no data. So the presence of data and the having access to the right data that describes what is going on in the real world, what is actually the status of your asset, that is the basis of your decision making. And so when one starts looking at a digital twin, the core question is, what information do you need for your decisions? And you'll notice that there's nothing yet about a computer model on screen. What you're looking at there is really the nuts and bolts of owning something. Whether this is your house or your car, you would need to maintain it. You'd need to decide when you're going to maintain it. Your business drivers as an individual owning a car are to minimize your cost of ownership and to not waste money. And you'd base that on data. And sometimes that data is going to be that funny sound that you heard from your CV joint. And that's data. Or maybe it's information that pops up on your dashboard in the car that says you need to service. And then you take a decision that says, I will now book my car in to the local service station to have its regular maintenance done. So now let's have a look at the rest of this picture. When we're designing new assets, those of us on the call that are involved in the initiation of assets, we know that 3D design is now the way that we do engineering, and through the design process and the documentation of that process, we develop these 3D BIM models. Again, this is the topic of this conference. When one goes through the construction process with a digital twin in mind, then the construction as-built and the construction records and the product records, those are also brought into that 3D BIM model. And as a result of all of that, a real asset is created. And so, to the degree that you synchronize the information development in the physical and the virtual world on the right-hand side and left-hand side of this picture, you are then able to, at the point of commissioning, have a virtual model with the information and geometry that accurately reflects the physical model. But what about assets that are already constructed? I think the vast majority of the assets that we will be using for the next foreseeable future are existing assets, as opposed to the new ones that we will construct. And so for the new assets, there is a process of reality capture. And this week on Tuesday, Shoaib was talking about scan to BIM. And this reality capture process is how we capture the geometry and the characteristics of those assets and convert those into a retrofit 3D BIM model. A digital twin is really a derivative of all of this, where the real world physical attributes are reflected in the virtual world. So it's the geometry, the shape, the size, the position of the real asset is reflected in the geometry, shape and size and position of the virtual asset in a suitable platform like a GIS or a BIM model. The characteristics of the components in the real world asset are reflected in the characteristics and components of the classification within that BIM model. And so once the link between the real world and the virtual world is established, we're able to close this loop. And that loop really is the operational loop that occurs with the owning of every asset. Now, in a digital twin, because of the technology available to us and the ability to create an architecture that links these pieces together, we can close the cycle of analyzing the condition of an asset, making the right decisions, acting upon that and changing the physical world, and then reflecting those changes back into the virtual world and continuing to analyze the data. Now, the data is not static. Data changes all the time, and the condition, the behavior, and the performance of the real assets changes over time. And so the regular measurement of what the real asset is performing like, how it is behaving, those measurements then happen on a regular basis and should be fed into the database that sits behind all of this. Now, in some cases, those measurements are going to happen every second. In other cases, they might happen once a year or twice a year. And so the application of this conceptual model on screen really depends on the type of asset that you're looking at and the way that that asset needs to be measured in order to take the right decisions. And you will hear that I'm using the word decision very often because this principle of a digital twin is not about taking away the power of the user or the engineer or the owner. It is about supplementing the information that we would usually have, which is traditionally a pile of paper, and taking the richness of integrated digital information, digitalizing the way we record it, and then transforming the way we look at our assets. And so digital twins really do support digital transformation of our industry. We've all heard about machine learning and artificial intelligence. The value that I see machine learning adding into this picture is to start for certain repeatable processes, for certain trigger events, to put an artificial intelligence on top of the data that says when certain things happen, certain defined actions need to be taken. So, for example, if the data analysis on a water treatment works shows that the water pressure in an incoming line drops significantly, indicating that there would be a pipe burst or a total shut-off of incoming water, we could program a system within the management system of that water treatment plant to shut off the pumps that are pumping from the settling tanks, because there's no use in the pumps running. In fact, they would get damaged if the whole system ran dry. And so machine learning provides us with an opportunity to have certain automatic trigger events that lead to certain predefined actions. Sometimes those actions are going to be notifications, and so rather than a data process changing the physical world directly, it could send a prompt to a human being, an operator, to say something is happening here that indicates a possible problem or a possible opportunity, and draws their attention to that opportunity so that the human can then act on the opportunity. So machine learning really is a potential benefit to the profession through the digital twin process. Machine learning also requires lots of data, and so the development of digital twins as a means to gather and manage the data about the assets is really a key to unlocking the potential of machine learning and artificial intelligence. So let's look at some of the values. In the transportation and infrastructure world, the ability to gather and manage information centrally might lead to many different benefits of optimization, of analysis of logistics, of looking at modularized construction. In the utilities world, definitely some of the examples I've just quoted on water treatment works, on the electrical networks, and in construction, plant automation. Other benefits in the building world, specifically around how the building performs and our ability to tweak and tune the building through its life cycle to make sure that it derives the benefits that were intended. And in mining and resources, very, very significant opportunities for digital twins, both of the mine itself and of the plant and machinery that work on the mine. I'd like to look at this model of the digital twin that we've looked at and see what are the groups of activities involved. So right in the middle, the loop of the operational cycle is really the world of the owners and operators and their business processes. So if you're an owner and an operator of assets or a portfolio of assets, you may consider developing digital twins of your assets to assist you in the process of managing them. Other players in that space are the data scientists and those professionals that are involved with developing the architecture to pull all of these systems together. There are so many moving parts that it is not conceivable that any one off-the-shelf product can deliver a digital twin. Rather, it's a case of pulling all these pieces together and orchestrating them into a holistic system that benefits from all the different types of technology to then create an integrated digital twin. When it comes to the actions and the way that we operate those assets, your facilities management and OpEx world are really the key players there, and behind them are the decision-making processes and systems in the CapEx world. So when one looks at the development of a portfolio and where to spend next, where to tweak your operational models, etc., your decision making then leads into your operational world and managing those facilities and ensuring that they are delivering as best they can. Those of us in the design world and the planning world, there's a lot of changes already happening in the way that we design, in the way that we deliver our product, and our changes and the transformation that we are facing is really staying abreast with technologies and the way that we need to be modeling and delivering the inputs to the digital twin from a greenfields perspective. The survey and mapping world is being influenced greatly by scanning technologies and photogrammetry, and the way that digital twins and BIM of brownfields are creating a new demand for capturing reality. And already we're seeing survey companies across the continent looking to adopt new ways of working and acquire a new skill set of modeling and reality capture. The IoT, the Internet of Things world, is, I believe, going to really come to life in the infrastructure world when we start connecting the real and the virtual worlds together. The sensors, the technology around automatic detection, around image interpretation, all of those technological capabilities feed into the ability to gather information, to automate that into the digital twin, and then use that growing data source as a basis for analysis. We started by talking about information, and information is really the key behind this concept. Without proper, well-managed, curated and safely guarded information, the digital twin is meaningless. It's just a pretty picture. And so the practice of document control, of information management, is becoming more and more important on projects. Having professionals who understand information systems, who understand codification, they are becoming the stars in the story. Without their careful management of information, the digital twin will die. Every part of the digital twin and all of the various different actors live within or operate within one single container of information. So that central common data environment must be set up carefully, because each of the different role players, each of the different components that are involved, all of them are going to be working off a single interconnected set of data. So it doesn't necessarily, and it probably won't be, one single database. It'll be a multitude of databases. It'll be a multitude of applications. But the environment needs to be consistent, and that's why the CDE is called a common data environment. It's not a common data platform. It's not a common database. It's an environment where all of these different types of information, whether it's condition information, whether it's financial information, whether it's operational information, all of those different types of data exist within an environment where they can be accessed, and where all the different stakeholders and role players can then put information in, process information, and get information out. So to do that, there are a number of challenges that face each of us, and those challenges are different for all of us. So let's start off with the design houses. One of our biggest challenges is to adopt. In that colourful slide that I showed with all the different role players, each of those role players are at varying different degrees of adoption of BIM and adoption of information protocols and adoption of working in intelligent 3D models, not just 3D graphics. And so for us, in the design space, we need to recognize the new roles and skills that we need to develop and make sure that we are equipping our team members with those necessary skills. We need to understand how our way of working needs to change as we deliver products to different timelines, and we work in different mediums, and even contracts, the way that we accept responsibility for various different parts of the digital process. All of those are changes that we need to anticipate and embrace. The survey world, you're already being disrupted, whether it's drones or scanners. You are seeing the world through a different lens, and your clients are starting to ask for different products, and your future relies on how you embrace those technologies and how you equip yourselves for that new type of work. There is immense collaboration opportunity in the sensing world, and in the sensing world I've seen such incredible case studies of different types of technologies being used to capture and gather and manage data. Some parts of the world, for example, are using cell phone technology and the accelerometers and GPS inside a cell phone to gather information about road condition, and are calibrating models to find average road condition so that cell phones, which we all have, can be used widely to see where the problem areas are in a road network, for example. There are great opportunities on the way for the facilities and asset management world. And what we're experiencing in the industry is a strong pull from the operational cycle of an asset to say, don't just let BIM stop at construction. Use that information into an asset information model and provide information in a structured, integrated manner to assist those who are responsible for the operational part of a project. And that is the part that I'm most excited about BIM. Seeing how BIM can transform our commissioning process and our operational process, regardless of which asset we're looking at. The world of automation and prediction really is looking for professionals and scientists who understand coding, who understand how to put systems together and how to do the systems architecture. As I said before, the digital twin is not a software package that you can download. It is something that you need to develop based on what your requirements are. And then data science, likewise. There are new emergent skills in the engineering faculties at universities. Our students are being taught different things, and this is essential if we're going to have the necessary skill sets to deliver on these possibilities. The font on this one is big because it's so important. We have to have standardized information management practices. And so that talks to our standards with regards to codification of components and assets, our ways of managing information in common open formats. Because there are so many of us, we need to have the greatest opportunity possible to share information. If all of our information is in different formats, if all of our information needs to be reprocessed every time it needs to be integrated, we take a big step backwards. And so I believe there is a lot of effort and diligence required to standardize how we work together as an industry. And then there are, with that, new technology opportunities, new skill set opportunities to do with hosting and visualization, to do with how we share information, how we put it all together. And so, colleagues, if we take a step back, then I hope that I've shown you how we can then take the old and the new and put them together. That we can take engineering and bring it into the modern world by managing our information, by digitizing our information, by digitalizing the way we work and change our design processes, acquire the new skills, and ultimately that we can transform our industry, and that through the use of BIM and the continuation of BIM into digital twins, that we can transform the built environment in Africa, and that together we can engineer a better tomorrow. Thank you very much.